As programs get bigger, they get messy. But it's not necessarily because they're doing something more complicated. They might just need to do the same thing over and over again. And sure, copy-paste seems fine, but what if you need to change something? What if something breaks? Well, now you have to remember every single place you pasted that in order to make the needed change. That's painful, time-consuming, and it's easy to get wrong. To solve this issue, we use a function. Now, hearing this word may transport you back to math class, but don't worry. While the name is borrowed from mathematics, it's really easy to wrap your head around. While it can get more complex, for now, let's use this definition. A function is a set of instructions that you give a name. And just like a good friend, you can call it whenever you need. If you need to use the instructions given in a function, you use whatever you named it to make a function call. Now, this allows you to make the instructions once, and then you can reuse that wherever it's needed. And the best part is, if you need to make a change, you only have to do that once, and then it's reflected everywhere it's used. Now, one thing to consider with this is because these instructions will be used in different places, you may need these operations done on different things. In many cases, you can give a function an input, or even multiple inputs, and then it will return something back to you. I hate to do this, but it is kind of like the formulas you learned in math. To find the area of any rectangle, you just multiply the base times the height. For that, the instructions are always the same, base times height. But the size of the base and the height can be different for every rectangle. Let's talk about a more fun example. A vending machine. A vending machine has certain things it does to dispense whatever's inside of it. It may rotate a coil that has a snack in it, causing it to fall in a place where you can get it. Or it may have an arm that will move and carry a drink to wherever you pick it up from. You give the machine enough money and then you punch in the numbers or letters of whatever you want. And that is your input. Then, assuming the machine is working correctly, it will give you your desired snack. And that's the output. Now, this is going to be a little bit outside of our scope, but there are some vending machines you can't see into at all. They may tell you what they have in them, they may tell you how to operate them, but they won't show how they actually work on the inside. This happens in functions too, and that's a concept called abstraction. But we don't need that yet. I'm just bringing it up now. I'll stop there. The last video was all about loops, and I mentioned that loops do not break any of the rules we've talked about so far. That's true with functions as well. Everything still runs one step at a time in order. However, once a program reaches a place you've told it to call a function, it jumps to that function, and then it will follow those instructions in order until the end, where it will jump back to where it was called. And that is why it's handy for organizing a program. You can have these functions act like organization boxes, and you can use them as many times as you want, wherever you want. They make things cleaner and more manageable, and they are used all over the place, like in a video game. If you have multiple enemies, they may reuse the same logic by using functions. That way, if the developer wants to change the behavior of the enemies, all the enemies, they only have to make a change in one spot. So let's tie everything we've talked about so far together. We can use a few things to build a program. The default behavior is sequential steps, but you can redirect a program using decisions or conditionals and repeat instructions with a loop. Those are the basic building blocks. But now we have functions, which let us group all these things together and give them a name. It allows us to think about a set of instructions as one big idea, and therefore organize better and build more complex programs. But there's still at least one major component missing. And in the next video, we'll look at how programs remember things. Thanks for watching.